Welcome to section 2.2, Separable Equations. Objective 1. Define a separable equation. A separable equation is a type of differential equation that can be solved by isolating x terms and y terms on opposite sides of the equation. This allows us to integrate each variable separately. For example, the equations dy dx equals y squared x times e to the power 3x plus 4y, and dy over dx equals y plus sine of x are separable and non-separable respectively. In the first equation, we can factor the dE as f of xy equals y squared x e to the power 3x plus 4y into x, the quantity x e to the power 3x times the quantity y squared e to the power 4y. But the second equation, there's no way of expressing y plus sine x as a product of a function of x times a function of y. The differential equation is separable if it can be written in the form dy dx equals g of x f of y. In this form, we can rewrite the equation by isolating x and y. So first we'll multiply both sides by dx when we get dy equals g of x times f of y dx. Then we'll divide both sides by f of y to get 1 over f of y dy equals g of x dx. Once the equation is separated, we can integrate each side individually. So say h of y equals 1 over f of y. Then we'll integrate both sides. We'll take the integral of both sides. And after integrating, we get capital H of y equals g of x plus capital C, where capital H of y and capital G of x represent the integrals of lowercase h of y and lowercase g of x, respectively, and capital C is the constant of integration. This leads to a solution that expresses y in terms of x, either implicitly or explicitly. Note that there's no need to use two constants in the integration of a separable equation, because if we write capital H of y plus C of 1 equals capital G of x plus C of 2, then the difference C2 minus C1 can be replaced by a single constant C. So when we integrate on both sides, we'll have technically two constants, but we can combine them into just one constant. Okay, and this is the first technique that we are going to learn in solving differential equations. So objective 2, solve separable equations. And so we have 4 separable equations here that we're going to look at together. Let's take the first one. All right. The quantity 1 plus x times dy minus y dx equals 0. Okay, so remember, to solve separable equations, we need to write the equation in separable form. So we need all of the x terms on one side and all of the y on the other. So let's do that first. Okay, so I have my equation here, and I'm going to move this y dx to the other side. Next, I am going to get my dy with my y term and my dx with my x term. So I am going to divide both sides by 1 plus x, the quantity 1 plus x, and y. When I do that, I now can simplify both sides. So the 1 plus x on the left side cancel, and the y cancels. And that leaves me 1 over y dy equals 1 over 1 plus x dx. Okay? So next, after moving things until one variable is contained on one side and the other variable on the other side, I'm now going to integrate both sides of the equation. So we'll take the integral of the left side and the integral of the right side. Okay, so this integral turns into the natural log of y, and the right side turns into the natural log of 1 plus x plus c. Okay. Now I'm going to exponentiate both sides in order to remove the log. So when I take both sides to e, exponentiate, so I would get e to the natural log y, e natural log plus c. Okay, and so now I can simplify this. So my left side will just turn into the absolute value of y, and my right side I can split up into 2 factors. Okay, and so when I simplify that, I have absolute value of y, 1 plus x, and the absolute value plus, it's multiplied, my apologies, times e to the c. All right, we are going to let e to the c equals c, where c is an arbitrary arb. Oh, I'm spelling this incorrectly. Let me fix that. Arbitrary constant. Okay, so we're just going to make it c, and so we'll have y equals c times the absolute value of 1 plus x as our solution. Awesome. All right, our next problem here, we have dx minus e to the power 3x dy equals 0. So let's use a different color. All right, we're going to write our equation in separable form. So I'm going to move e to the power 3x dy to the other side. Now I want to get one variable contained on one side and the other variable contained on the other. So I am going to divide both sides by e to the power 3x. So I get dx over e to the power 3x equals e to the power 3x over e to the power 3x dy. And so then my e to the power 3x cancel. All right. And so now I'll have Let's move this e to the power 3x to the numerator, so that will give me a negative exponent. Dx equals 1 dy. Okay, so next is to integrate both sides. When I integrate both sides, because I'm dealing with e, I'm going to need to use u substitution. So let's set that up. So we're going to let u equal negative 3x. So then du dx will equal negative 3. Okay, I want to substitute in for dx, so I want to get dx by itself. So du will equal negative 3 dx when I multiply both sides by dx. Then if I divide both sides by negative 3, I'll get negative 1/3 du equals dx. Okay. Now that I have this, I can rewrite my integral, right? So I'll have negative 3x is u, and then dx is negative 1/3 du. So I'll have du, and I can place my negative 1/3 in the front because that's a coefficient. And then on my other side, I still have the integral of 1 dy. Okay, so now we can integrate. So on the left side, I will get negative 1/3 e to the u equals the integration of 1 would just be y, and then plus c. Okay, so now I want to get y by itself to write out my solution. So I'll have y equals negative 1/3 e to the power u plus c. Okay. Now I can substitute in my value, my term for u. So that's y equals negative 1/3 e to the negative 3x plus c. Okay, and that is my general solution. All right, our next problem is dy dx equals 3y squared x squared. Okay, so again, we want to get our equation in separable form. So I'm going to multiply both sides by dx over y squared in order to get my y variable contained on one side and my x variable contained on the other side. So I'll have dx over y squared times dy dx equals 3y squared x squared dx. Not d. Where's my, there we go. Y squared. Okay, I didn't have to subtract or add anything on either side because it is written in separable form. So now I can simplify. So my dx's here cancel on the left and my y squares cancel on the right, leaving me 1 over y squared dy equals 3x squared dx. Okay. I'm going to move my y squared to the numerator, so making my exponent negative. It's just easier to differentiate. Okay, So next I'm going to take the integral. So y minus 2 dy, not minus 2, to the power. It looks like a minus 2, doesn't it? So I'm going to fix that because that can be confusing. So to the power negative 2 dy, and then I'm going to integrate 3x squared dx. Okay, great. Now when I do that, I will get negative y to the negative 1 equals, and I could have rewritten this with the coefficient on the inside, but either way, or outside, sorry. If I move my coefficient out and then I take the integral of x squared, I would be multiplying that by 1/3 x cubed plus c. Okay, so the 3 here's cancel. So I have negative 1 over y equals x cubed plus c. Okay, so now I want to get my y by itself. So I'm going to multiply first everything by negative 1 to get rid of the negative sign. So I have negative x cubed minus c. Then y is in the denominator, so I need to flip all of the ratios. So on the right side, I'll flip, and on the left side, I will flip as well. So flipping just means I'm multiplying both sides by the reciprocal. So if I multiplied both sides by y, and then I divided both sides by negative x cubed minus c, I would get my general solution here. Okay, awesome. Okay, our fourth problem is going to be this lovely trig DE problem. The sine 3x dx plus 2y cosine cubed 3x dy equals 0. All right, first thing we need to do is write the equation in separable form. So I'm going to move my second term to the right side. Okay, and then I need to get one variable contained on one side and the other variable contained on the other side. So I'm going to move all my x to my left and my y to my right. So I'm going to divide both sides by negative cosine cubed of 3x. This is 2y cosine cubed 3x over cosine cubed 3x negative dy. Okay, so then the negatives cancel. The cosine cubed 3x cancels over here. And so I have negative sine 3x over cosine cubed 3x dx equals 2y dy. All right, x one side, y other side. All right, so I'm going to use some trig rules to just help me open up this ratio. So negative sine 3x over cosine 3x times 1 over cosine squared 3x dx equals 2y dy. Now, according to my trig rules, I know that sine over cosine is tangent. So this would be tan 3x. And I know 1 over cosine squared is secant squared 3x dx equals 2y dy. Okay, so now I'm going to integrate both sides. So the tan 3x secant squared 3x dx 2y dy. Okay, we're going to use u substitution to help us simplify this left-hand side. So we'll let u equal the tan 3x. So then du dx equals 3 secant squared 3x. Okay, so we want to substitute in for dx, so it's all in terms of u. So if we're solving for dx, we know du equals 3 secant squared 3x dx. Okay, so if we divide both sides by 3 secant squared 3x, we'll get du over 3 secant squared 3x equals dx. So we'll enter in the u substitution. So we'll have the negative tan 3x is u times the secant squared 3x, and then dx now equals du over the secant squared 3x. Well, 3. I forgot my 3. 3 secant squared 3x. Okay, and then we have 2y dy. Okay, simplifying, secant squared 3x cancels, and I can move the 3 in the denominator outside of my integral. So I have negative 1 over 3 u du equals 2 y dy. Okay, applying the integral, we have negative 1/3 times 1/2 u squared plus c equals 2 times 1/2 y squared. Okay, so we then have negative 1/6 u squared plus c. The 2's here cancel, leaving us with y squared. Okay, so y squared equals negative 1/6, the u we know is tan, 3x, this is tan squared because it's u squared, plus c. And that is our general solution. Oh man, that was fun. Wouldn't you agree? Okay, so now for these next 3 exercises, we're going to find a solution to the given initial value problems. So in the first 3, we found the general solution, and so for these next 3, we're going to be taking it one step further. Now that we have an initial condition, we can find a unique particular solution to our DE. So in this problem here, we have the DE 3x squared plus 4x minus 4 over 2y minus 4 with initial condition y of 1 equals 3. Okay, So this is very similar to all of the others. We're still going to do all of the steps, except for now that we have an initial condition, we can find C. So let's first write our equation in separable form and then move our variables until one variable is contained on one side and the other variable is contained on the other side. Since this is y prime, I know I can rewrite this as dy dx. So let's start off with that. Dy dx equals 3x squared plus 4x minus 4 over 2y minus 4. Okay, I'm going to multiply both sides by 2y minus 4 and dx. So I will get 2y minus 4 dy equals 3x squared plus 4x minus 4 dx. Okay, so now I have terms on one on each side. The y is on the left, x on the right. So now I'm going to take the integral of both sides, 2y minus 4 and the 3x squared plus 4x minus 4. Okay, so now let's take the integral. So for the first one, 2y, so I'll have 2 times 1/2 y squared minus 4y equals 3 times 1/3 x cubed plus 4 times 1/2 x squared minus 4x plus c. Simplifying, 2 here's cancel, so that's y squared minus 4y equals 3's cancel, x cubed, 4 divided by 2 is 2, so plus 2x squared minus 4x plus c. Okay, we're now going to let y of 1 equal 3. That's our initial condition. This is going to let us find c, which will then allow us to find our particular solution. So if x is 1, y is 3. So we'll have 3 squared minus 4 times 3 equals 1 cubed plus 2 times 1 squared minus 4 times 1 plus c. Okay? So that's 9 minus 12 equals 1 plus 2 minus 4 plus c. So negative 3 equals negative 1 plus c. And so c equals negative 2. Since c equals negative 2, we then have our solution, y squared minus 4y equals x cubed plus 2x squared minus 4x minus 2. Okay, now this is an implicit solution. Okay, all right, and we want an explicit solution. So we're going to have to work a little bit more to get our answer in equal to just y. So let's take this and find our particular solution. So I'm just going to rewrite what we got on the top here. Okay, so we can rewrite this in a quadratic form. Let me show you. So we have y squared minus 4y minus the quantity through x cubed plus 2x squared minus 4x minus 2 and set it equal to 0. Okay, so this is kind of written in quadratic form where we have x squared plus bx plus c, our constant. So we're going to make the x term on the right hand side our constant in our quadratic. And now we're going to use the quadratic formula to help us find the solution for y so that we can write it in explicit form. All right, so we know our quadratic formula. Usually in terms of x, right, we would be solving for x, but in this case we're solving for y, all right, would equal, and actually let me write this in a different one so we don't get it confused. So y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and so this would be our a, our b, and this whole thing would be our c. Yes, that whole thing. So y equals negative 4, so that would be a negative 4, plus or minus, there we go, square root of b squared. So that would be negative 4 again, minus 4ac. Divided by 2a. Okay, so we can simplify this. So we have 4 plus or minus the square root of 16 minus, this is a minus 2. I forgot my minus sign because I was going to say minus 4 times this, but we are subtracting this quantity. So let's add a negative in there. There we go. So then the negative and negative will make this positive. And then we have 4 times x cubed plus 2x squared minus 4x minus 2. There we go. All over 2. Okay. So let's see here. Just want to make sure I'm doing everything correctly, and I am. Okay. So now we have 16 plus 4 times this whole quantity. What we can do is we can factor out. Next, we can factor out 4 under the square root. So when we factor out a 4, we will be left with y equals 4 plus or minus 2 square root 4 plus the quantity x cubed plus 2x squared minus 4x minus 2. Okay, so 16 has a factor of 4, and then our second term has a factor of 4. So if I factor out, then I'd have 4 times, 4 plus 1 times the x cubed plus 2x minus 4x minus 2. And then the square root of 4 is 2, which is why I now have a 2 in front of my square root. All right, and this is all over 2. So now I can simplify. 4 divided by 2 is 2, and 2 divided by 2 is 1. So this would be the square root of 4 plus Well, not 4. My apologies. Let's simplify that in this step as well, actually, so we don't have to rewrite it. So let me show you everything, actually, just so that you have it in your notes. So when you're reviewing it, you understand the process. So I did 4 divided by 2 plus or minus 2 square root 4 plus x cubed plus 2x squared minus 4x minus 2 all over 2. That way, when I simplify this, I get 2, and then these cancel. So now I have 2 plus or minus the square root, and I can combine like terms here. So I can drop the parentheses. So 4 minus 2 is just 2. So x cubed plus 2x squared minus 4x plus 2. Okay, and so this has 2 solutions, right? But we only want one solution. So we know that y of 1 equals 3. So y of 1 equals 2 plus the square root of 1 cubed plus 2 times 1 squared minus 4 times 1 plus 2. That simplifies to 2 plus or minus the square root of 1 plus 2 minus 4 plus 2, which simplifies to 2 plus or minus the square root of 1, which is 2 plus or minus 1. So our answer will be either 3 or 1. And we want the solution that gives us a value of 1. So when I add 1, I get 3. When I do 2 plus 1, I get 3. When I do 2 minus 1, I get 1. So I know then that y equals 2 plus the square root of x cubed plus 2x squared minus 4x plus 2 is my particular solution for this initial value problem. All right. All right, next we have y prime equals e to the power oh goodness, e to the power of negative y times the quantity 2x minus 4 with an initial condition y of 5 equals 0. So I'm going to start with my dE. I'm going to rewrite y prime as dy dx equals e to the power negative y 2x minus 4. I'm going to multiply both sides by dx and divide both sides by e to the negative y. E to the power negative y. I forget to say power. I need to say power. Okay. So I'll have 1 over e to the power negative y dy equals 2x minus 4 dx. I can move e to the power negative y to the numerator. So that's e to the y dy equals 2x minus 4 dx. Then I'm going to integrate 2x minus 4 dx. So when I do that, I'll get ey equals 2 times 1/2 x squared minus 4x plus c. 2's cancel, so I have e to the power y equals x squared minus 4x plus c. So we're going to let y of 5 equals 0. So when we do that, we now have e to the 0 equals 5 squared minus 4 times 5 plus c. E to the 0 is 1. 5 squared minus 20 plus c. So 1 equals 5 plus c. So c equals -4. Since c equals -4, we have e to the y equals x squared minus 4x minus 4. We now need to get y out of the exponent location. So we'll multiply both sides by the natural log. We'll apply the natural log to both sides. It's not really multiplying. And so that will eliminate the natural log of e when we move the power to the front using the log rules. And so y equals the natural log of x squared minus 4x minus 4. Okay, and that is our particular solution for this initial value problem. Awesome. All right, our last initial value problem for separable equations is dy dx equals y squared x minus 2xy plus x over x squared minus 1 with an initial condition of y of the square root of 2 equals 3. Okay. All right, so let's first, let's see here. Let's first distribute out the x in the numerator. That way I will have my x term and my y term, because I notice each of the terms in the numerator here have an x. And if I want to get the x on one side and y on the other, I'm going to need to be able to separate that. So let's do that first. Dy dx equals x over y squared minus 2y plus 1 over x squared minus 1. Okay, so now this is more easier to work with. So I can multiply both sides by dx, and I can divide both sides by the y squared minus 2y plus 1. Okay, that way I can get my x on one side and my y on the other side. So I'm going to have 1 over y squared minus 2y plus 1 dy equals x over x squared minus 1 dx. Okay, now that y squared minus 2y plus 1 I can write in factored form, because the two factors would be y minus 1 squared dy. Right side would stay the same. So now we can take the integral of both sides. Okay, and we're going to need to use u and v substitution to help us. So we're going to let v equal y minus 1. So dv over dy equals 1. So then dv equals dy. Then for the right side x, we're going to let u equal x squared minus 1. So du dx is going to equal 2x. So du will equal 2x dx. And to get our u slash v, but in this case use substitution into our integral. We need to we could substitute x dx for u. So if I divide both of these by 2, I would get 1/2 du equals x dx. Oh man, that was not a good bracket. Let's rewrite that. Oh, much better. Look at that. Okay, so now let's substitute in. So we'll have 1 over v squared dv equals 1/2, and then 1 over u du, because we want it all in terms of u and v. So when we apply the integral, we are going to get v to the -1, but the middle step would be to move this to the numerator, actually to move both of them to the numerator. Well, let's take the natural log of this one actually, so let's keep it. I want to do the natural log for this problem. Okay, so I'm going to move v to the numerator, and so that will get me negative v to the -1, not dv because we already applied the integral, equals 1/2 natural log u plus c. Okay, so next I'm going to resubstitute in my original expression. So I know what v is, so that's negative y minus 1 to the -1. And the natural log u is x squared minus 1 plus c. Okay, so now my goal is to get y by itself. Okay, so let's continue. So I'm just going to rewrite what I had on the other screen so I can continue. 1 over y minus 1 equals 1/2 natural log x squared minus 1 x squared minus 1 plus c. Okay, let's multiply both sides by y minus 1. So it's 1/2 natural log x squared minus 1 plus c. Okay, and then I can divide both sides by this second quantity here so that I get y minus 1 by itself. So y minus 1. So then that would be negative over 1/2 natural log x squared minus 1 plus c. And then I would still have, let's see here, the negatives in front. Good. So now I can add 1 on both sides. So 1/2 natural log x squared minus 1 plus c plus 1. Okay, so now we'll let our initial condition come into play, which is y square root 2 equals 3. So when we substitute that in, we'll get 3 equals -1 over 1/2 natural log square root 2 squared minus 1 plus c plus 1. So that would be -1 over, and if we take the square root, squared would get us 2, and then we have 2 minus 1, then we would have 1, and the natural log of 1 is 0, and so then we have 0 times 1/2, which is 0, plus c, which would just leave us with c. So I'll provide that for you here. So that would be 2 minus 1 plus c. So negative 1 over 1/2. So this would equal 1. Let me write that a little clearer for you. So we have this equals 1. The natural log of 1 is 0 plus c. And then we still have plus 1 on the outside here. So then 3 equals negative 1 over c plus 1. Subtract 1, so 2 equals negative 1 over c. And so c equals negative 1/2. Okay, so now that we know what c is, we know what our particular solution is, which is y equals 1 negative, not negative 1, negative, and then 1 at the top, 1/2 natural log x squared minus 1 minus 1/2 plus 1. Okay. And then to help us kind of make this look a little prettier, we can multiply the top and the bottom of our ratio here by 2, just so that we can eliminate the fractions in the denominator. So when we do that, we'll have 2 in the numerator, and then if we multiply the first term by 2, that eliminates the 1/2. So we'll just have the natural log x squared minus 1, and then the other 1/2 times 2 would get us negative 1 plus 1. All right, and that is our particular solution for the differential equation. All right, that concludes section 2.2. Enjoy.